Hi, I'm SV Raman from Bangalore, India. I'm a physics tutor from class 8th to 12th. I have nearly 15 years of experience in education industry. I'm working in a school currently. I have completed my post-graduation in physics, B.Ed, and have 6 years of online experience through different platforms. UrbanPro is the great platform to me to get in touch with the different students with the different locations. Students can also contact with me and interact with a teacher and can learn happily for their academics. I have started my journey with UrbanPro from 3 years and nearly 100 plus students are mentored every year. Especially, UrbanPro is collaborated with Zoom and can easily schedule the classes and can get immediate notifications and class recordings as well. It's a great platform to me to mentor the different kinds of students during this pandemic year. And if we talk about my teaching and how to me stands from others, teaching is not that simple. Concepts are same, but how the concepts are reaching to the students in this digital era. Every students are not the same. Every student frequency is not the same. We have to pick the approach of learning method of the student and try to mentor them in easiest way. That makes my stands up between others. Today, we are studying with light, reflection, and refraction. Generally, what is light? Light is an optical sensation, what we can able to see. And today we are discussing about what is reflection, laws of reflection, properties of plane mirror, concepts of spherical mirror, parts of spherical mirror. Now, generally from everyday life, we are seeing from morning to evening. We are seeing the different kinds of objects. How we can able to see the object? Of course, with help of the eye, we can able to see. With help of the source of light, we can able to see. But what kind of physical parameter? What makes things to visible? How we can able to see that? During the day, the sunlight helps us to see the objects, and objects reflects light that falls on it. The reflected light, when received from by our eyes, enables us to see the things. We are able to see through a transparent medium as light is transmitted through it. Simple example, for example, you are seeing a table or a laptop or a flower vase. How we can able to see that object? Light rays are incidenting on an object. From that object again we are getting back due to reflection. And between that there is a glass sheet. Still you can able to see the object. That's what our topic is, light reflection and refraction. Now, what is reflection? Reflection means the bouncing of a light. The bouncing of a light from one surface to other surface. Simple example. Here you can see in the slide. Light rays are incidenting on a smooth surface. The total light rays are bouncing back. So this kind of reflection, we can call it as absolute reflection. Absolute reflection. Now, you can see that the light rays are incidenting on a rough surface and all the light rays are reflecting in n number of directions. This kind of reflection we can call it as discrete reflection. Discrete reflection. Clear? Next, we can study what are the laws of reflection. Once you can see that this is an incident ray reflecting back. Yes, the incident ray is incidenting on a plane surface, say an example mirror, and which is bounced back. Now, we are taking a normal. From normal to incident ray, this angle is incident angle. From normal to reflected ray, this angle is a reflected angle. Now, incident ray, a reflected ray, incident angle, and a reflected angle. What are the laws of reflection? What are the laws of reflection? Now, incident ray is incidenting on a polished surface which bounce back. Now, the first law indicates incident ray, reflected ray, normal all are in same plane. Repeating again, incident ray, reflected ray, normal all are in same plane. Incident angle is equal to reflected angle. So angle I is equal to angle R. So these two are the laws of reflection. Clear? Now, reflection of light by a plane mirror. What is plane mirror? Generally, you can see this is the plane mirror. Yes. Now, this is the polished surface or reflected surface. Backside, this is coated surface. Clear? Now, how that reflection will be? For example, there is an object. You can see the pen inside of the mirror. There is an object. Object where we placed from the mirror, that distance is object distance. Okay. The image also form inside of the plane mirror at the same distance. You can clearly see that now the image inside of the mirror. Fine. Now object distance, how much I placed, image also will be the same distance inside of that. Second thing, object height is equal to image height. How much the pen size, the height, and the image height also the same. For example, once we raise the right hand for the mirror, that is left hand. This is one. And we can able to see the image inside of the mirror. Inside of the mirror. We can call it as a virtual image. Clearly we can study. Now, the first point, object distance is equal to image distance. Object distance is equal to image distance. Second point, object height is equal to image height. Object height is equal to image height. Third point, we can see inside of the mirror image. That's called as a virtual image and erect image. Fourth one, if you raise the right hand for the mirror left hand, once you can see in the picture, we placed P. We are observing Q inside of the mirror. So that's called as laterally inverted. Laterally inverted. Clear? So these are all the four properties of plane mirror. Next, what are spherical mirrors? What are spherical mirrors? Spherical mirrors we are getting from spherical glass. Spherical glass. Now, what kind of images will be happens in the spherical mirror? Take a spoon. Spoon inside of the curve, our image will be downwards, which is inverted image. If you turn the spoon, then head will be top again, which is erect image. Erect image in the sense of head and head should be the same. And inverted image. If you see the spoon curved inwards, our head will be ulta, inwards will come, up and down. This is called as inverted image. Now in details we can study what is spherical mirrors, how it will be formed. Now we can study from the spherical glass how to prepare the spherical mirrors. Now take a spherical glass. Take a spherical glass. Just I'm drawing here. Yes, spherical glass. We cut that uniform thickness. If you cut the uniform thickness and remove the remaining parts, this is plain glass sheet. Plain glass sheet. And the plain glass sheet we coated. Either one of the side you coat it. This is plane mirror. Plane mirror. Yes. Now spherical glass you can take and you cut. This is the way. The remaining parts you remove it out. This is convex lens. Convex lens. Both sides bulged outwards. End parts are very thin. Center part is very thick. You can see over here. Both sides bulged outwards. End parts are very thin. Center part is very thick. This is convex lens. convex lens. Now, again take the spherical glass. Yes, again take the spherical glass. You cut, this is the shape. This is the shape, and remaining parts remote out. This is also the lens. Both sides bulged inwards. End parts are very thick. Center part is very thin. Yes, this is. End parts are very thick. Center part is very thin. So this is concave lens. Concave lens. Now this convex lens, any one of the side you coat it. We coated. Now what it prepared? Convex mirror prepared. Convex mirror prepared. Now if light rays are incident over here, light rays will be reflected back from the polished surface. So bulged outwards as a polished surface, bulged inwards as a coated surface, we can call it as a convex mirror. Now this convex lens, any one of the side you coat it. Bulged inwards as a reflected surface, bulged outwards as a coated surface. Bulged inwards as a reflected surface, bulged outwards as a coated surface. This is concave mirror. Fine. Finally, we prepared convex mirror and concave mirror. Now this is the concave mirror. Bulged outwards, we coated. We coated, bulged outwards. Bulged inwards, reflected or smooth surface. So we can able to see. Yes. So this is concave mirror. Now I'm redrawing concave mirror and what are all the parts of that. Bulged inwards as a reflected surface, bulged outwards as a coated surface, we can call it as a concave mirror. Now we can study the parts of a concave mirror. From this point to this point, the length of a mirror, say an example MN, the length of a mirror from curved inwards, the length of a mirror, we can call it as aperture. Aperture. The center of the aperture, we can call it as pole. Imaginary line through the pole, there is an imaginary line through the pole, call it as principal axis. This is principal axis. Now, object at infinitive. Say an example, take a concave mirror and focus it at infinitive distance. Now you can see in front of me, what are all the objects you can able to see. There is an infinitive. Now, infinitive means an object at infinitive, the light ray passes parallel through the principal axis. This is the principal axis. Parallel through the principal axis, light ray is incidenting. Cause of the curved inwards, light ray will come downwards. So, which reflects back. This refracted ray is meeting the principal axis. This point we can call it as focus point. Focus point. The distance between focus point and pole, we can call it as focal length. Focal length. Double up the focus point, center of curvature. Center of curvature. Center of curvature to the pole, radius of curvature. Radius of curvature. So here, center of curvature to the pole, radius of curvature, focal length, focus point to the pole, focal length. So R is equal to double up the focus point. Clear? Now we can study parts of convex mirror. Convex mirror. Bulged outwards as a reflected surface, bulged inwards as a coated surface, we can call it as a convex mirror. Now, the length of a mirror from top to end, the length of the mirror we can call it as aperture. MN aperture. The center of the aperture, pole. Imaginary line through the pole, principal axis. Already we discussed in concave mirror, same as well convex mirror. principal axis. Now, object at infinitive. Light ray coming from infinitive distance. Yes, parallel to the principal axis. If object at infinitive, light ray should be parallel to principal axis. Now, cause of curved outwards, light ray will be reflects upward direction, which won't meet that principal axis. In concave mirror, this reflected ray met the principal axis, but in convex mirror, away from the principal axis. What we are doing, we are extending that line over here. There is an imaginary source. So inside of the mirror, the focus point will be formed. This is pole. And the distance between pole and focus point, focal length. Focal length. F is focus point. So double up the focus point, center of curvature. C is center of curvature. Now center of curvature to the pole, radius of curvature. Radius of curvature. Yes. Now here also the radius of curvature is equal to double up the focus point. Clear? Yes. Now we studied what is light, what are the reflection of light, laws of reflection, and preparation of spherical mirrors, parts of the spherical mirrors. Thank you for viewing my class. I hope this video is helping to you the better understanding through practical nature of reflection of light. If you need more classes, see my profile and see my videos with the children. We can meet soon through UrbanPro. Thank you so much.